In this video, we'll learn about the closure, which is an important or interesting thing about the nested functions. Last time we talked about the nested functions, about the enclosing scope. There are two benefits from the enclosing scope. The first one, it helps us to apply one of the software engineering principles, the DRY principle. DRY is do not repeat yourself. Anytime you find yourself is copying paste some code and keep repeating it, you are repeating yourself. If there is a bug in any single code, there will be a bug in every copy paste code. So we have to find a way to make the code more elegant, avoiding this copy paste. The nice thing about the enclosing scope, if there is some code that, for example, repeat a lot, you can move as an inner function, and then this function will be just called to achieve a specific scenario. And given that this function is already accessing all of the enclosing scope for it, you don't need to have a function with a lot of parameters to be, or arguments to be passed. It will be just ready for you to use. And from time to time, I do that in my work. I remember a recent scenario where I was like writing something to a video, and I needed to write from time to time in different places and doing a lot of repetitive logic. So I moved all of that to an inner function, and then I just kept passing to it only the variable things, and all of the other things that should be in the closing scope I left it. Today we will learn about another application for that, the closure. The closure means your function, your outer function is returning the inner function, not calling it. So now we learn about, we can assign function, we can pass a function, we can return a function. We are going to return our inner function as it is. So let's say we have an inner function inner, we'll return inner, not an application for it like inner of 10 and 20. We'll return inner itself. Now here is a very interesting thing in Python. The returned function will remember the enclosing variables even after the return. So you think like in normal cases, when a function is returned, its internal local variables will be destroyed in a way or another. Now if you returned the function will keep remembering the variables that it depends on them. Remember, and this is a mistake, common mistake, it remember the variables, not the values themselves. So if the variables change it in a way or another by the end of the outer function, it keeps remembering the variables themselves. Later we should see like some connection between the Python decorators and the closure itself. So let's see an example for that. Here we have an outer function that receives variable x. It defines local variable y. And here we have another function f, inner, that take an f and return x plus y plus f. Observe that the function inner has a local variable f, but it can see the enclosing variables x and y. Now I'm returning here inner itself, not inner of 2 or 3, I'm returning inner itself. The function outer, when we call it with some number, it's returning f for us, which is an inner that can see x and y. What is the value of x? We passed here with 10. So x will always be 10. What is the value of y? The last value of y is 20. So this inner function have some 10 plus 20 plus some f. Now if I pass 30, it will return 10 plus 20 plus 30. If I pass 40, it will be 10 and 20 plus 40. And so on. Okay, observe this syntax, don't be confused about it. Outer of 100 is going to return for us an inner function that know that x is 100 and y is 20. And now this is now a function here, replace outer of 100 with a function f. F of 5 is calling it here with parameter value 5, and then we are adding 100 plus 20 plus 5 to get 125. This slide is very fundamental. Do not keep going unless you really get what's happening here. Let's see another example to see how things might maybe a bit different. I'm defining here an init function. The init has a class inside it. So this is the first time for you to see a class defined inside a function. We can have nested function and nested classes and all of this flexibility in Python. The class has two methods, load database and add ID. Observe that the load database is using the user's add, which is actually in the enclosing scope itself, 1 and 2. And as we would like to do the plus equal here, then there's some assignment. So we need to have a non-local to make it like allowed to change with a plus equal. And we have also another function called add ID. It take an ID and it do the following. If the ID not in the users, it add it. Otherwise, it's already there. So the logic is load the data, add ID if it doesn't exist. Observe here, user IDs is just appending without non-local, because the appending would be okay with the mutable data structure. But this is out of scope for now. Now, the class is we used it here to create a database, and then we loaded the database. Observe, if you put the line 19 after them, there will be a problem, because the load database will try to get the user IDs which isn't binded at the moment. Okay, it will give you the unbound error. So now we created the list, we created an object, we loaded the data. But what are we returning here? We are returning db.addID. We are returning this method. Now here in the main, we call the init function to get an object ID adder, and then we are using it in several places. We are passing it to this function and this function. So adder here is adding 4, which is already exists. Then 5, it will be cool, we will add it. 6, it will be cool, and we will add it. So this is exactly the same application as we were using in the previous slide. I'm just complicating things a little more. I'm showing you mainly that here have a class inside an init function. I'm returning a method here as a closure, and then this method has been called several times. So although these guys are calling functions, behind the scene this function is actually this method inside this class. Again, this is just an application for the same concept. I would like to show you a case where things might be a bit counterintuitive for you. Let's trace this code. Maybe take a minute to read this code and try to guess why the output is 222 instead of 012. Take a minute to do that. We have a function here. The function has a list, and we are appending in the function f. So we are appending set of closures here. You are building f internally, and we're appending f. So this will be list of closures, and we are returning here list of closures. Okay. Now observe the point here. We have a for loop for I from 0, 1, and 2, and the f here returning I, which is an enclosing parameter. But the point here I is a free variable. I is changing from a step to another, and this is what we mean by closures are capturing the variables or the values. When we are done with this function, we have 3 functions, all of them connected with variable I, which ended up with the value of 2. So when you try here to call all of them, they will give you 2 and the 2 and the 2. Why? Because f here will not capture the value 0 and 1 and 2. It will capture the variable I, and the variable I by the end of this function will have the value of 2. So this is a bit a tricky thing, so to be careful from such free variables that keep it change in such a way. There is one workaround for this problem as following. We are going to pass the variable I, we will give the function f a default variable I, and give it a default value of I itself. This way we are actually forcing it to, actually this time it's now looking to its own local variable I. So the way we change it, the problem is we actually give it its own copy from I. So the point is if you have such a very free variable, then you need to pass it internally in a way or another, so that it keep looking to the value instead of the variable. So here we are capturing the variable of an enclosing scope, but here we have our own copy of our local value. That's all. Closures are interesting, so try to play with it.